Scaling up versus scaling out, your guide. Welcome, everyone, to Tech Unpacked, the podcast that demystifies the digital world. Today, we're diving into a fundamental concept in computing infrastructure: scaling. Specifically, we're going to explore the two primary ways systems grow to handle more demand: vertical scaling versus horizontal scaling. When do you scale up versus scale out? Let's find out. In the world of technology, scaling simply means making your application or system capable of handling more work. Think about a popular website or a streaming service. When it launches, it might only have a few users. But if it becomes a hit, millions of people might try to access it simultaneously. Without proper scaling, the system would buckle under the pressure, becoming slow, unresponsive, or even crashing altogether. So, scaling is about ensuring your digital services remain fast, reliable, and available no matter how popular they become. Let's start with vertical scaling. This is often called scaling up. Imagine you have a single computer that's running a particular application. As more users come along, that computer starts to struggle. Vertical scaling is like upgrading that single computer. You give it more power. You might add more RAM, a faster processor, or a larger, quicker hard drive. You're making the existing machine more capable. Think of it this way. If your car isn't fast enough, you could swap out its engine for a more powerful one. That's vertical scaling. You're improving the existing unit. In the server world, this means taking your current server and giving it more CPU cores, more gigabytes of memory, or upgrading its network interface card. It's about increasing the resources of a single machine. Now, what are the advantages of vertical scaling? For starters, it's often simpler to implement, at least initially. You're dealing with one machine, so there's less complexity in terms of software architecture. Data management is easier because everything is on a single server, avoiding the challenges of data synchronization across multiple machines. For applications that rely heavily on a single database, vertical scaling can be a very effective solution, as databases are notoriously difficult to scale out horizontally without significant architectural changes. It also means fewer servers to manage, which can simplify operations. However, vertical scaling has its limitations. The most obvious one is physical hardware limits. There's only so much RAM you can put into a single server, or so many CPU cores a motherboard can support. Eventually, you'll hit a ceiling. Another major drawback is that by relying on a single machine, you create a single point of failure. If that one powerful server goes down, your entire application goes down with it. There's no redundancy. Also, upgrading a server often requires downtime, meaning your service will be unavailable while the new hardware is installed. And finally, the cost per unit of resource tends to increase significantly as you buy more powerful, specialized hardware. A server with 256 gigabytes of RAM isn't just double the price of one with 128 gigabytes. It's often much more expensive. So, when might you choose vertical scaling? It's a good option for applications with predictable, moderate growth or those that are inherently difficult to distribute, like certain legacy databases. If simplicity of management is a top priority and you're not anticipating massive, unpredictable spikes in traffic, vertical scaling can be a solid, straightforward choice. Now let's turn our attention to horizontal scaling, also known as scaling out. Instead of upgrading a single, more powerful machine, horizontal scaling involves adding more machines to your system. If vertical scaling is like putting a bigger engine in your car, horizontal scaling is like adding more cars to your fleet. You're distributing the workload across multiple, often less powerful servers. Imagine a popular restaurant. If it gets too busy, vertical scaling would be like hiring a super chef who can cook 10 times faster. Horizontal scaling, on the other hand, is like opening more kitchens and hiring more chefs, or even opening entirely new restaurant locations. You're increasing capacity by adding more independent units. The advantages of horizontal scaling are numerous, and for many modern applications, compelling. First and foremost, it offers virtually limitless scalability. You can keep adding servers as demand grows, theoretically without hitting a hard ceiling. This makes it ideal for applications with unpredictable or rapidly growing user bases. Secondly, and crucially, horizontal scaling provides high availability and fault tolerance. If one server goes down, the others can pick up the slack and your service remains operational. There's no single point of failure. You can also perform rolling updates, taking servers offline one by one from maintenance or upgrades without interrupting service. Cost effectiveness is another major benefit. Horizontal scaling often relies on commodity hardware, less expensive, off-the-shelf servers, rather than specialized high-end machines. This can significantly reduce capital expenditure. Cloud providers, for instance, excel at horizontal scaling, allowing you to easily spin up or shut down virtual servers as needed, paying only for the resources you consume. This elasticity is a game changer for managing variable workloads. However, horizontal scaling introduces its own set of complexities. Managing a distributed system with many servers is inherently more challenging than managing a single one. You need mechanisms to distribute incoming requests across your servers, typically using a load balancer. Data consistency becomes a major concern, especially if you have data replicated across multiple machines. Ensuring all copies of the data are up to date and consistent requires careful design and sophisticated database solutions. Your application itself needs to be designed to be stateless where possible, meaning any server can handle any request without needing information from a previous interaction on a specific server. This often means a more complex application architecture, such as microservices, where different parts of your application run independently. So, when should you choose horizontal scaling? It's the preferred method for high-traffic web applications, cloud-native services, microservices architectures, and big data processing. If high availability, resilience, and the ability to handle massive, unpredictable growth are critical, horizontal scaling is almost always the answer. It's the backbone of most large-scale internet services we use every day. Choosing between vertical and horizontal scaling isn't always an either-or decision. Sometimes it's a both-and approach. For example, you might horizontally scale your web servers, but vertically scale your primary database server for maximum performance and easier data consistency. The best approach depends heavily on several factors: your application's specific needs, its growth patterns, your team's expertise, and your budget. Consider the cost. Vertical scaling can have higher upfront costs for premium hardware, but horizontal scaling might incur higher operational costs due to managing more machines and the complexity of distributed systems. Think about complexity. Vertical scaling is simpler in the short term, but horizontal scaling offers more flexibility and resilience in the long run, albeit with more architectural overhead. Performance requirements, data consistency needs, and the importance of high availability will also heavily influence your decision. In summary, vertical scaling is about making one machine more powerful, scaling up. It's simpler, good for predictable loads, but has hardware limits and a single point of failure. Horizontal scaling is about adding more machines, scaling out. It offers virtually limitless scalability, high availability, and cost effectiveness for commodity hardware, but introduces architectural complexity. The key takeaway is to understand your application's requirements, its growth trajectory, and then choose the scaling strategy or combination of strategies that best meets those needs. There's no one-size-fits-all solution in the dynamic world of computing. And that wraps up our discussion on vertical versus horizontal scaling. I hope this has given you a clearer understanding of these critical concepts. Join us next time on Tech Unpacked for more insights into the ever-evolving landscape of technology. Until then, keep learning and keep building.